Hello everyone, welcome back to the course of Semiconductor Devices and Circuits. Myself, I am Ananda Kumar, Assistant Professor in the Department of PCE, BVIT, Nasapur. Today's topic is about common base configuration, input and output characteristics. Coming to the transistor. Transistor has been invented by the three scientists, William Shockley, Barden and Brayton, in 1947 at AT&T Bell Laboratories. After the invention of the transistor, almost the semiconductor industry has been much revolutionized, and the miniatured electronic components which we enjoy, it is because of the transistor. And Gordon Moore has been predicted that for every year, the number of transistors that are manufactured in a chip are going to be doubled. So by 2030, we expect trillions of transistors to be manufactured in a single IC, integrated circuit. Coming to the transistor construction, basic transistor construction, when we join semiconductor materials such as N-type, P-type as well as N-type semiconductor, we have a NPN transistor, or conversely we can also join P-type, N-type and P-type semiconductor, we can have a PNP transistor. We make sure that when we construct these terminals, the emitter terminal or the emitter region which is moderate in width, because there is no specific purpose for the region of the emitter. The base region is very thin in region because the light carrier has to be transmitted from emitter towards the collector. We make base region to be thin, and the collector is large in width in order to dissipate the heat that has been generated at the collector junction. Not only that, we also have the dopings. Emitter is heavily doped in order to emit more number of charge carriers. Base is lightly doped in order to make less recombination at the base region, and there is no such region, so collector is moderately doped. Likewise, we can construct an NPN transistor or a PNP transistor. Coming to the symbolic notation of this transistor, the emitter, the arrow represents a current flowing direction from P-type to N-type semiconductor. Current always flows from P-type to N-type semiconductor, and the emitter and the collector are both are similar. So whichever is there N-type, the same N-type will be taken here at the collector side as well. That's how it is called NPN transistor. Similarly, in case of PNP transistor also, the current flowing direction is always represented at the emitter terminal, and the current always flows from P to N, current always flows from P to N, and this opposite to this P-type, we have another P-type, PNP semiconductor. Coming to the common base configuration. We keep base as a common terminal, and we apply input at the emitter terminal and observe output across the collector terminal. Because it is being a three-terminal device, in order to use it as a two-port network model where it consists of two input terminals should be there and two output terminals is there, we can make one terminal common to both input as well as output. That is how we get a common base configuration. So generally we use NPN transistor, and at the emitter we mention the arrow, current always flows from emitter P-type to N-type semiconductor. Coming to the point here, this in order to operate this transistor in active region, this emitter junction has to be in forward bias and the collector junction has to be in reverse bias. The emitter junction is made forward bias by connecting the N-type semiconductor or this emitter terminal to the positive terminal of the battery, and opposite side collector N-type should be reverse biased. This again it has to be connected to positive terminal of the battery such that this collector junction is reverse bias. This is nothing but VEE because at the emitter, and this is VCC at the collector side. Now the input parameters of this transistor, the input parameters of these transistors are, we have the voltage VEB at the input side. At the input side we have a voltage VEB, as well as a current entering at the input side of this common base configuration is IE. Similarly, at the output side, we also have a voltage called V. This is CB, VCB, voltage VCB, and the current entering here is IC. So the output parameters here are VCB, IC. The input parameters, input parameters will decide input characteristics of a transistor, and output parameters decides output characteristics of a transistor. Coming to the input characteristics of a transistor, as we mentioned earlier, input characteristics are plotted for input voltage, which is in this case V, common base configuration. So input is emitter, so VEB versus input current IE. Since it is operating in a forward bias region, the correct characteristics here are similar to the PN diode forward bias characteristics. Up to some voltage, there is no flow of current. After that, current will increase exponentially. However, in order to draw the input characteristics, we keep output voltage VCB constant. When we increase the VCB voltage, what happens? When we increase the VCB voltage, say for example, we have two junctions here. We have this N, P, N, three semiconductors we have, emitter, base, collector, three terminals we have, and we have two junctions JE, JC, because this is reverse biased. When we increase the reverse bias voltage, the depletion region width will increase. The depletion region width at collector junction will increase. The increase in depletion region, this depletion region will try to penetrate towards the base region. When we increase this output voltage VCB, we can see that output collector junction depletion region width will increase, and it try to penetrate towards the base region because base is being lightly doped. And this will result in a change in base width. The change in base width is coined as base width modulation, and this has been found by the Early, and hence it is also called Early effect. Due to Early effect or base width modulation, when we increase this reverse bias voltage, this will increase the depletion region width. Since the base region is going to be reduced, it will decrease the recombination current in the base region, hence IB will reduce. Of course, when the base recombination is less in the base region, whatever charge carriers that has been emitted at the emitter terminal, it will flow towards the collector terminal, which means that the gain in this particular configuration, which is coined as alpha, which is output current ratio of output current to input current IC by IE, will increase. The gain is increased. However, if we keep on increasing the reverse bias voltage, we may get the situation called punch through or reach through, where the base region will completely vanish. It is because of the base region or base current, the transistor is called current controlled device. Say in this equation, IC output current depends on the input current alpha times IE plus some reverse saturation current IC E0 or IC B0. Say in case of common base, this is in case of common base configuration. In case of common emitter configuration, similar kind of expression we can find, which is IC is equals to beta IB times beta IB plus 1 plus beta times IC B0. This altogether is called IC E0, reverse saturation current in common emitter configuration. The output current in this transistor, output current depends upon input current. By varying the input, we can observe their increase in the output current. Hence, it is called current control device. But we should not get the situation punch through, where the usefulness of application of the device such as amplifier will get terminated. So these are the consequences of early effect one should remember. Hence, when we increase the reverse bias voltage VCB to be 5 volts, the emitter cut-in voltage we can observe very quickly. Hence, the curves will move towards left side. So this is about input characteristics of a common base configuration. Similarly, we can see output characteristics. In output characteristics, we draw output characteristics by taking output voltage on x-axis. In this case, output voltage is VCB, and output current in common base configuration is IC. VCB versus IC. This common base configuration, since as we have seen earlier, the current gain in common base configuration is nothing but ratio of output current to input current, which is IC by IE. Because IC is approximately equals to IE, since IC is in milliamps, IE is in milliamps, base current being very less, it is in microamps, IC is approximately equals to IE, hence alpha is closely equals to 1. Generally, it varies from 0.95 to 0.995, and it is approximately unity. Hence, in the curves, we cannot see that much slope here. When say for example, IB, when fixing IB constant at 0 microamps, which is at cutoff region, and then subsequently when we increase this voltage current IB, there will not be much slope will not be observed here in case of common base configuration characteristics. In case of common emitter configuration characteristics, we may see the slope because of the relationship beta is equals to alpha by 1 minus alpha. We can see beta is equals to, we can see that beta ranges from 49 to 250. We can get more slope and more amplification in case of common emitter configuration. But whereas in common base configuration, the alpha is 1, hence the curves are straight. So in the output characteristics, we have 3 region of operations. One is cutoff region and saturation region, and also we have active region. This is a region where transistor acts as amplifier. And also, due to the early effect, we will take an imaginary voltage, early voltage, and we can take this curves towards left hand side like this. Thus, in common base configuration, we can see that there is a current gain of unity, and we should observe base width modulation, and also we also seen that current control device, how the output current is being controlled by the input current, and what are the effects of base width modulation, which are nothing but increase in gain of the transistor and change in the base width, and we can also see in the punch through or reach through. Finally, we apply this signal, AC signal, to get amplification in the active region of the output characteristics of a device. This is all about common base configuration, input and output characteristics. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.